Hello everyone, welcome to the Sprint 3 presentation of Team Rush Hour. So in this presentation, we'll be giving a entire briefing of our project. So coming to the agenda for this presentation, so we'll be discussing about the roles and responsibilities of our entire team, and we'll be giving the entire project overview, and we'll be briefly discussing about the technologies and the syntactical diagrams of the entire project, and a briefing about the product backlog along with this particular sprint metrics and the sprint backlog as well. And we'll be ending off this with the sprint retrospective and the product demo.
Myself, Avnash Manchala, I worked as a full stack developer and UX designer of our team.
So myself, Ratanjana Singh Varpu, so I am the team lead, Scrum Master, and the full stack developer for our team.
Myself, Kaundinya Pedapati, and I was the full stack developer of the team.
Yeah, my name is Saira Madara. I am full stack testing engineer.
Hi, this is Pranay, and I'm the lead AML engineer for the team.
Hi, this is Murli, and I'm AML engineer and tester.
Hi, this is Uday. Myself, I am a ML engineer cum tester.
My name is Sujit Suprabhat Tupki. I will be working as a full stack tester and quality assurance manager for the team.
So, coming to the improvements, we got feedback from the professor. So, based on the feedback, we improved product backlog. We also modified the API screenshot to include the descriptive part for the APIs. And we also had sprint planning with a proper explanation. And coming to the problem statement, healthcare today can feel pretty overwhelming. Patients have to juggle through a lot of test results, prescriptions, and appointments. And on the other side, doctors and hospitals are buried in paperwork and tons of patient data. It's easy for things to fall through the cracks. So we started thinking what is a better and smarter way to manage all these things. That's where our solution Uspark comes in. Yeah. So Uspark is nothing but it's a simple, smart, all-in-one platform that helps both patients and doctors to stay organized. For patients, we have an AI chatbot called UHeal. You just answer a few questions and it can help figure out what might be going on and even schedule a consultation through online or in person. And for doctors, USpark make it easy to manage appointments and medical records. Plus, we have built a powerful ML tool called USEC that can analyze medical images and save doctors a ton of time and helping them make faster decisions.
This is our team working agreement. These are all the terms that we have agreed as a team. Brief description of the agreement is that our team, Rush Hour, is driven by the aim of producing a viable result at the end of the project duration, striving to give our best at meet pre-decided plans and goals, and ultimately ensuring customer satisfaction. Individually, each member is responsible for their task. So here are the different terms. First is individual accountability. As this is a big project, we as a team, individual in the team, we will be doing our parts, understanding the importance of contribution. Second term is communication and resource sharing. So as a team, we use different tools for communication such as Zoom, WhatsApp, Google Docs, and other software to facilitate collaboration. Third term is participation. We all have agreed to participate and be active. Fourth is openness and helping. All the team members have agreed to help each other if someone is stuck at something. Fifth is work division. Work is assigned to all the team members according to their interest. Sixth one is meeting. We as a team have decided to connect with each other on Zoom, and also based on the sprint schedule given and the sprint planning, a sprint retrospective is conducted to examine what went well and what other improvements are needed. These are some of the different roles in the team. Team lead, Scrum Master, Quality Assurance Manager, ML AI lead developer, full stack lead developer, UI UX designer, and tester.
Coming to personas, Dr. Saurabh John, a 40-year-old senior radiologist, Mark Thompson, a 45-year-old bank manager, Emily Carter, a 38-year-old lab technician, and Lisa Brown, a 30-year-old software employee, each face unique healthcare challenge that highlighted the need for AI-driven and user-friendly digital health solutions. Dr. Saurabh seeks AI tools for faster diagnostics, centralized patient history, and efficient scheduling. Mark needs a template system to manage his family's health records and track recurring issues. Emily requires streamlined appointment management, record tracking, and seamless HMS integration to support hospital operations. Lisa values convenient, on-demand healthcare access, trustworthy medical advice, and digital symptom guidance without Hospital visits collectively, their personas emphasize the growing demand for smart, efficient, and actionable healthcare technologies. Next slide.
Yeah, these are the core features of our application. Basically, we designed our core features based on the user stories we got. Therefore, the core features are booking appointments, hospital recommendations, chatbot, one card, and usage. When it comes to the booking appointments, user can book appointments with the doctors as well as they can schedule the appointments and also cancel the appointments with the doctors. Whereas hospital recommendations, based on the location of the patients, they can visit the hospitals nearby with the help of the chatbot as well. And when it's come to the chatbot, we can take initial assessment from the chatbot, and also it will give you a solution to you. If you are satisfied, it's good to go, or else they will suggest a doctor nearby for you. And when it comes to the one card, all your details are stored in that place. For example, if you have any past medical history or something, it will store in that. And after the consultation also, it will store the details into it. So it is about the one card. Everything details like insurance details, everything will be stored in that. And USEG, when it's come to the USEG, it is a biomedical image processing unit where doctor can use it for the image segmentation to get clear output where the disease will be. And these are about the core features here. Next. And this is the MVP design. I used it to create by using Figma, and we provide two logins: login as doctor and login as patient. And when it comes to the down, it is the doctor dashboard. You can see the calendar availability and patient records and everything here. And you can see the usage is there in the doctor. And for the next one, he can upload the image and he will get the output from it. And next. And sorry, and bottom is the chatbot interface, which is called as UHIL, where you can see the preliminary diagnosis and suggestion of hospitals as well. Next. And this is a patient dashboard. We can see the health news, ongoing treatments, and any prescriptions available here. And when it's come to the next one, it is the U card I mentioned earlier. This is, you can see a name and details of the patient and also the insurance details and everything at one place. And if you scan this QR code, you will get the files and records of the previous assessments as well. Next.
So when it comes to the technologies, like we are using React for the front end of the application and Redux to store the data for the front end. And Axios we are using the connection between the front end and the back end. We are actually doing the API calls via it. And we are using Node.js for backend creation of APIs and with the use of Express.js. And Material User we are using for like developing the front end UI of the application. And Python we are using for like developing the AI/ML algorithms and etc. Can you go to the next slide? Yeah, so MongoDB, we are actually storing the data, like the document data of like user records and everything. And AWS, we are using to store the S3 kind of data because of images and documents which we want to store that we cannot store in MongoDB. So that's why we are storing in S3, and then Flask APIs and PyTorch. So these are completely related to AI stuff. Yeah, next one. So Jira we are using for organizing our works and everything, and Docker we are using to containerization of the production environment which we want to. And Figma we have actually designed, actually Avinash designed it everything. So VS Code where we are using the platform to write the code and everything. Postman we are actually using it for like testing the APIs, and so GitHub where we are actually hosted the code. Next.
Yeah, coming to the algorithms and models, we started with the RAG, which allows the chatbot to search documents and generate accurate knowledge-based response. This helps provide users with the reliable medical information, not just generic answers. For analyzing medical images, we use DenseNet, a model that reuses feature efficiently, making image processing faster and more accurate. We also added ResNet, which helps solve vanishing gradient issue in the deep network. This improved our network ability to detect issues in medical images with greater precision.
Yeah, so coming to the diagrams, so we have few diagrams that are necessary for understanding the project. So this is our architecture diagram. So in this thing we have the patient doctor, which are two important components of our entire application, and also we have an admin portal. So I'll just give a briefing about this. So everything we needs to be stored in the backend part, which is the storage part of the application. So predominantly we are using MongoDB and S3 bucket for the storage purposes, and also for the backend, that is API, database, and fetch requests. We are making through Axios, as mentioned earlier by KP. So coming to the admin, so the admin can actually fetch the doctor details from the MongoDB and also can view these details particularly, so that they can give a particular verification status to the doctor, so that the doctors can be verified accordingly. And also for the doctor as well, we have the USEX. So the doctor needs to fetch the images from the patient uploads, and also that is also happening from the S3 bucket as well. And so the upcoming appointments as well, so when the patient books and appointments, the appointments are ultimately saved in the backend, which are fetched by the doctor portal as well. So coming to the patient, it's vice versa. We have the UHIL in this side. So UHIL as well, we need to chat accordingly. The chat needs to be stored for assessment storing purposes, so that the patient can ultimately see their assessments whenever they need. So it is stored in MongoDB as well. And the image uploads also happens here as well. And also medical news, we are fetching it from a global medical news API. So that's also a backend part of our application. So this is basically how the architecture of our entire application looks. Next. And coming to the context diagram, this is a miniature version of our entire application. So we have the Uspark in the middle and the doctor and the patient. So we have the output and the input parts over here. So the thing is that UHIL, with the use of UHIL, the patient must be able to chat and get a preliminary diagnosis. So that's how UHIL is designed, that we can see here. And you said the doctor needs to upload those images so they can get a viable segmented result as an output from the USEC. So that can be seen here as well. And coming to the doctor and the patient integration thing, so the doctor must be able to see the upcoming appointments, should receive some kind of a notification regarding the appointments as well, and the patient needs to make these appointments. This must happen in real time, so that the patient, whenever they make an appointment, the doctor gets the appointment, so that appointment clashes does not happen. This is how the entire flow of the context within the application happens. Next. Yeah, coming to the sequence diagram, so this is how the things go. So on the top we have seen UHIL, USEG, Mongo, S3, and MedNews API. So coming to the front end and the back end, so the front end part is where the user completely interacts, and the user doesn't have to know about the back end. So within the front end, the patient chats with the UHIL application, and also they can see their assessment details through the patient dashboard as well. So this is how the major UHIL works. And coming to the doctor part, they need to work with the USEC so that they can upload the images, and also they can view their appointments as well. And coming to the MongoDB and S3 bucket, so every detail is stored in MongoDB. So starting from the patient details, their onboarding details, their chat histories, and everything are stored within MongoDB. All the image uploads and the verification documentation uploads made by the doctor, so that they can get verified. All these things are stored in the S3 bucket that we can see over here. So based on the need and the necessity, these details can be either posted to MongoDB or fetched from MongoDB, and vice versa with S3 bucket as well. And coming to the MedNews API, we need to get relevant world news data regarding the health. So for that purpose, we are using MedNews API. Next. And coming to the state diagram, it's a pretty simple state diagram. So once the user logs in, say as a doctor, as in patients of the user logs in as a patient. So the states are mentioned here in yellow boxes. So once they complete their initial assessment, if they're satisfied, then they're good to go. They can get a preliminary diagnosis from the chatbot. Also, if they're not very much satisfied with the doctor, they can, sorry, the assessment, they can schedule an appointment with the doctor, so then they can get a better diagnosis from the doctor in person, or a virtual as well. And coming to the doctor state, so the doctor state starts from where they get an appointment. So once they are verified, they can receive the appointment, so that they can make the necessary diagnosis regarding the patient. So they get the appointment details as well, and they can also use the USEC to um, process those images. Once they upload the images to USEC, they get a received process output, and this output is necessary to send the report to the patient. So that's how the entire state goes. And the final state, of course, is the logout state. Yes. Next. And coming to the class diagram, we have the patient, doctor, and insurance. So everything details are needed to be stored as well. So the patient has a patient ID, age, and the gender and the weight of the patient as well. So we have few more fields, right? Because we have the medical history also we are storing, and we have few other like fields for the patient as well. For the doctor, these are the primary states: the doctor ID, specialization, and their experience, and the verification status as well. And also insurance, we have the insurance ID and the provider name, the start date and the end date of the insurance. These are the few classes and their identities. Next.
Yeah, coming to Sprint 2 recap, Sprint 2 we delivered 4 big wins. Hospital recommendation turned to each patient's assessment and location. A secure one called QR that bundles personal and insurance data. An upgraded chatbot that triggers symptoms and book visits. And AI image analysis to spend doctor diagnosis. We finished around 29 of 36 planned story points. It's about 80% of the sprint score.
Yeah. When it comes to the product backlog, I will give you a quick overview of it. Basically, we designed our product backlog based on the user stories we got, like patient, doctor, admin. For example, appointment bookings, you heal, you seg, like that. These are the features we implemented. Our product backlog checks all the requirements of the users for helping them to get everything from our application. This is simply about the product backlog, and these are some of the features. Here next. And this is the video call feature, patient record feature, everything we mentioned earlier, and these are the features we defined from the user stories. And next, simply it is about the whole product backlog. Yeah, you can skip this. Yeah.
Coming to Sprint 1 summary, in Sprint 1, we laid the groundwork for UHeal by delivering core access and safety features. For patients, we enable multi-option sign-up and the ability to add insurance details directly to their profiles. For doctors, we built a registration flow with credential uploads, while admins gain dashboard to review and approve those credentials or lock account spending re-verification. We also integrated our first clinical AI slice. Doctors can upload images and instantly receive heat map or segmentation outputs to a diagnosis. Together, these capabilities create a secure entry point for users, establish a trusted provider network, and showcase the platform AI potential from day one. This is all about Sprint 1 summary. And coming to Sprint 1 bundle chart, like from day 1 to 11, we began the sprint with about 30 story points of work to do. First week progress we was slow while we set up our tools and make sure everything will be running good and understand the tasks. The origin line actually line stayed above the blue ideal line, meaning we are bit behind. From February 18th to 20, we cleared several small tasks at once. You can see a sharp drop here in the orange line as catching up. And February 21 to 27, we found a steady working place, like both lines moved down together, sharing we were finishing work almost exactly as planned. From February 28 to 1st March, we finished a big piece of work sooner than expected. The orange line dipped below the blue line. And from 2nd March to 7th March, only few small fixes and polish were left, so the line goes down in little steps.
Coming to Sprint was focused on developing key features for both patients and doctors to enhance the user platform. For patients, we enable password resets, personal profile management, security storage, and sharing of medical records, and flexible appointment scheduling, including choice between virtual and in-person consultations. We also integrated appointment confirmation, easy rescheduling or cancellations, and introduced AI-driven preliminary diagnosis and doctor recommendations based on symptoms. For doctors, we built functionalities to manage their profiles, securely handle patient health records and notes, upload medical images for AI processing, and receive real-time notifications about appointments, bookings, or cancellations. Overall, Spring balance patient-facing features and backend support for doctors, ensuring a smoother, smarter healthcare experience. Next slide. Coming to sprint to burndown chart. This was sprint to burndown chart. The blue line shows the ideal progress while the orange line represents our actual progress. Initially, no work was done from March 11 to 13 as we took a break after completing the previous sprint, following by holidays for Holi and spring break. Some members worked during the break at their own pace, but overall progress lagged. Although we resumed steady work later due to vacations and a few unexpected absences, we couldn't fully meet our targeted story points. Yeah, it's about the sprint to burndown chart.
Yeah, so we have completed the sprint 2, but after completion of the sprint 2 we were lagging with few points behind, so we needed to ensure that we complete these particular story points by the end of the sprint 3, which is our last sprint as well. So these are few of the Sprint 3 story points. Like for us, we have completed most of the part regarding the full stack part and ML part separately within the Sprint 2 time. But for Sprint 3, our main focus was on to make the system look as much as ease through and also very sleek as possible. And also we wanted to make the integration look seamless for the users as well. So we worked on the integration part of the chatbot and in the USEG, which is the medical assistant as well. So these are few of the user stories which have considered. As a patient, we need to store past medical assessment law and also regarding the appointment things as well. And also one thing we wanted to make sure was that the integration part works fine and also everything looks in particular shape after the completion of Sprint 3. And these are the stories which you have considered. Yeah.
Coming to the test cases, we have written the test cases for the every user story that we have done is sprint. The first test case was regarding the past appointments and prescription, and we have verified that patients can log in and view the appointment history and prescription. The test case was passed, and next one was the such doctors by specialty and availability. We have checked if the doctors listing based on the user's selected filter, and we have passed the test case has passed. And next test case was the view doctor rating before the booking. The expected result was show the rating and reviews before the booking the appointment. But the issue is here, rating is not visible under the doctor profile. So that case was a passer. It has failed. We have failed the test case. And the next test case was the suggest in person or virtual based on the symptoms. We have validated that system recommends the constellation type based on the symptoms. Yeah, the test case was passed. Next slide. And next one was get potential diagnosis from biomedical images. Yeah, doctor upload an X-ray or MRI, and the system use the AI generated diagnosis. Yeah, the test case was passed. And next test case was the upload and store medical reports. The expected result was to upload and view the download past reports. The issue is the reports not storing properly or not visible later, and we have failed this test case. And next one was a choose virtual or in-person appointments. I confirm that the user can book their either type of appointment with confirmation shown. Yeah, we have passed the test case was passed. The next slide. The next one was to get the preliminary diagnosis from symptoms. A patient enters symptoms and system will provide an initial diagnosis. The test case has passed. And then last test case was regarding upload medical images for AI processing. A doctor uploads X-rays or CT images. The images is linked to the patient and ready for the AI. Then the test case has passed. The next.
Coming to completion of the stories for Sprint 3, so we have actually gone through like multiple stories which are created beforely and we haven't completed in Sprint 2 and we completed almost everything. So as a patient, I want to like view my past appointments and prescriptions, which we actually did almost everything in Sprint 2, but we didn't tested it properly. So we completed that part. And as a patient, I want to search the doctors based upon the specialty availability. So these functionalities were done. And as a patient, I want to see like ratings and reviews and doctors like before booking an appointment. So this is also done. So and creating a virtual option for a patient, like how he wants to connect with a doctor, like via virtual or like in person, which was also done. So can you go to the next slide? So here are the few other stories which we actually completed. So as a doctor, I want to upload my medical images of X-rays, MRIs, CT scans. So this is like very critical part where we actually take some time. So this was also done. Yeah.
So yeah, this is our team velocity. In this graph, the blue bar represents the committed story points and the green bar represents the completed story points. And the there, red dotted line represents the average velocity. In sprint 0, we were assigned 19 story points, out of which we completed all the story points and achieved 100% velocity. In sprint 1, we were assigned much higher story points compared to the previous sprint, which were 31 story points. As in sprint 0, this sprint, we this sprint also we were able to achieve 100% velocity by completing all the story points. In sprint 2, as you can see, we were assigned 36 story points, but we were able to complete only 29 story points. The story points assigned to us in sprint 2 were higher compared to the historical points assigned to us in sprint 0 and sprint 1. In sprint 3, we are assigned 30 story points and we were able to complete all the story points. The average velocity, as you can see, is 27.2 of all the sprints. Next slide. Okay, so this is our burn down chart. The blue line represents the ideal burn down, and the orange line is our actual burn down. That is the actual progress made by our team. As you can see, starting 7th April and 8th April, there was no work done because all the group members took a break from work because we had finished our last sprint. On 9th April and 10th April, on 9th and 10th April, we assigned the story points to every group member and everyone started working on their task. As you can see, from 8th April to 12th April, all the group members were doing their task assigned to them regularly. From 13th to 16th April, there was a delay because there was a dependency on some user story. We were able to solve the issue on 17th April and everything was back on track. Because we were working regularly on a task from starting, that is 8th to 12th April, we were ahead of our schedule and completed most of the tasks. So you can see that the actual burn down, that is the orange line, is below the blue line, that is the ideal burn down. From 17th April and all the other days till now, like we were working on our task as per our own schedule. And since this was our sprint 3, all the team members got used to their task they were assigned and were able to do it easily. But if we needed any help, we used to ask our team members. And the end, as you can see that 25th April and to 28th April, we were very busy doing the work because like previously were we had the idea that we had to submit our work by last week. So we were last days we were doing our work. Yeah. This is the committed ratio. As you can see, the gray bar represents the committed story points and the blue bar represents the completed story points. In sprint 0, we were given 19 story points and were able to complete all the story points, giving us 100% committed ratio. In sprint 1, we were assigned 31 story points and were able to complete all the 31 story points, which again gave us a 100% committed ratio. But in sprint 2, we were assigned 36 story points from which we were able to complete 29, which gave us 81% completed ratio. And in this sprint 3, we were assigned 30 story points and we completed all the story points, which gave us 100% completed ratio. Yeah.
Yeah, so the project demo, so we're gonna continue the project demo in the video, separate video, guys. Yeah. Can you go to the next slide? Yeah, same. Next. Next. Yeah. So yeah, over here, like if you can see here, like the API screenshots, like we're gonna explain like basic understanding of how we actually use the APIs. Like we have used Node.js and Express.js for like creating the APIs, and for API docs, we actually used for like Swagger. So where we actually created like API docs and everything. And here is the basic example of how we actually created the Axios instance, and then we actually connected to our backend APIs. Yeah. Next. Yeah. So these are our sign up APIs and also like verify doctor APIs which we created, and fetch profile APIs. So every time we actually use the Beaver like tokenization where we passing the token, and we are actually connecting via tokenization by JWT, and by which like we are achieving the authentication everything. Next. Yeah, here also like few other APIs which we are using for like this is for like chart with bot API. So this is actually connecting with our UHIL and USEC. So that's how we are actually connecting it. Yeah, next. Yeah, here the chatbot APIs also. Can you go to the next one? Yeah. So here, like you can check the entire flow and what are the things which you have done throughout the entire like this project and this work. And so here, like we can visit to this particular URL and you can see like what are the works we have done. Yeah, that's all. Thank you, guys.